understand the purpose of this service. Write memory by address allows the client to write data into the server, specifically at one or more contiguous memory locations. In the last video, we had a look into the details of the Write Data by Identifier, that's Service 2E. Now let's move forward and explore the next diagnostic service. It's called Write Memory by Address, or 3D service. Before we dive in, let's understand the purpose of this service. Write Memory by Address allows the client to write data into the server, specifically at one or more contiguous memory locations. Possible use cases of this service include clearing non-volatile memory, like erasing data stored in flash memory, changing calibration values, especially when these values are only accessible by a memory address. Let's now walk through the request definition for the Write Memory by Address service 3D. The request starts with service ID 3D. Next comes the address and length format identifier, a 1-byte value. Each nibble in this byte is encoded separately. Bit 7 to 4 defines the length of the memory size parameter. Bits 3 to 0 defines the length of the memory address parameter. Then we have the memory address, which is the starting point in server memory where data will be written. Its byte length is defined by the lower nibble of the format identifier. Next comes the memory size. This tells us how many bytes will be written starting from the memory address. Its length is defined by the upper nibble of the format identifier. And finally, we have the data record. This is the actual data the client wants to write into the server's memory. Let's now have a look into the positive response structure. The positive response for this service includes response service ID 7D, the address and length format identifier echoed from the request, the memory address also echoed from the request, and the memory size also echoed from the request. Now, let's go through the different negative response codes, or NRCs, supported by this service. NRC 13, incorrect message length or invalid format. This NRC shall be sent if the length of the message is wrong. NRC 22, conditions not correct. This NRC shall be sent if the operating conditions of the server are not met to perform the required actions. NRC 31, request overage. This NRC shall be sent in the following cases: if any memory address within the interval is invalid, if any memory address within the interval is restricted, if the memory size parameter value in the request message is not supported by the server, if the specified address and length format identifier is invalid, or if the memory size parameter value in the request is 0. NRC 33, security access denied. This NRC shall be sent if any memory address within the interval is secured and the server is locked. NRC 72, general programming failure. This NRC shall be sent if the server detects an error when writing to a memory location. Let's now go through the order in which the server evaluates the request and checks for possible negative response codes, or NRCs. First, the server checks for minimum message length. If the message is too short, it triggers NRC 13. Next, the server checks whether the address and length format identifier is applicable or not. If this check fails, the server sends NRC 31. After that, a total length check is performed to ensure the message matches the expected length for the service. If this fails, once again, NRC 13 is returned. Following that, is a check to ensure that the memory address and memory size are valid and supported in the current session. If any of these parameters are incorrect or unsupported, the server responds with NRC 31. Next, the system performs a security access check to confirm whether access is allowed for the requested memory range. If security access is not granted, it results in NRC 33, security access denied. Then, a check is made to ensure that all preconditions for executing the service are met. If these preconditions aren't fulfilled, the server will send NRC 22, conditions not correct. After this, a manufacturer or supplier specific check is performed to ensure that the data record being written is valid. If the data record is found to be invalid, a manufacturer or supplier specific NRC may be returned. And finally, there's a write verification check. This confirms whether the data was successfully written into the server's memory. If any error is detected during this process, the server returns NRC 72, general programming failure. If all the above checks pass successfully, then a positive response is sent for the requested service. Now, let's try to understand write memory by address with the help of a simple example. Let's assume that the client wants to perform a memory write using 2-byte addressing, that's 16 bits, and a memory size of 2 bytes. The client will send the request as follows. The service ID for write memory by address is set to 0x3d. The address and length format identifier is set to 0x12. Here, the value 1 specifies the length of the memory size and the value 2 specifies the length of the memory address. Next comes the memory address 4820, followed by the memory size 02, and finally the data record 8C. Now, let's look at the positive response from the server. The response service ID will be 0x7d. The address and length format identifier will echo the request value, that's 12. The memory address will also echo the request value, 4820, and the memory size will again echo the request, 02. With this, we've completed a detailed look into the write memory by address service, that's service 0x3d. In the upcoming session, we'll explore the clear diagnostic information service, that's 0x14. If you found this useful, don't forget to like, subscribe, and share with your fellow automotive tech enthusiasts. See you in the next video.